Hello guys, today we'll learn about the term filtration. Filtration is nothing but you can say that removal of the fine particles using the gravels, or you can say a kind of bed media. So the fine particles will basically be arrested in the different layers of the packing materials. So this is also kind of a column. So whatever particles have not been removed by the coagulation and flocculation unit will be removed by the filtration. There are a lot of filter media available in the market. We have sand, and sand can be either fine or coarse, so they are called as filter media, and the layers of sand can be supported on gravel, which will allow the filter water to move freely to the under drains and allow the wash water to move uniformly forward, sorry, for upward. Now the sand that we are going to use here should be free from dirt and other impurities, and should be uniform in nature and size, which we can find by the term called uniformity coefficients, which is the ratio of d60 by d10, and it should be hard and resistant. It should be such as not to lose more than 5% of its weight after being placed in hydrochloric acid for 24 hours. Now we will be briefly discussing the filter theory. Our main focus today is to solve some basic numericals. So the type of filters are basically three types. First one is the slow sand filter, then we have rapid gravity filters and the pressure filter. Filters can be classified on the rate of filtration basically. So slow sand, and rapid sand can also be divided into two rapid gravity pressure filters. And filters, when they are classified on the basis of gravity and pressure, they are indicated as gravity filter, pressure filter, and the gravity filter further can be classified as slow sand filter and rapid sand filter. Now slow sand filter, where the process of filtration is very low, and their use has been very can say obsolete nowadays, because they are basically preferred on smaller plants at hotter regions. Now in case of the and here the operation and cleaning is also a tedious job, where there is a loss of head on the filter head, or you can say filtering head or filtration head, which is limited to a maximum value of 0.7 to 1.2 meters. Now the efficiency, in terms of efficiency, the slow sand filter is basically very good at removal of the bacteria, which is 98 to 99%, and usually this is economical. Now the rapid gravity filters, which has a higher filtration rate as compared to the slow sand filter, which is going to treat a large amount of water. Now let's start solving some basic numericals. Now here is one example where we have to design 6 slow sand filter beds from the following data, where the population served is 50,000 people and the per capita demand is 150 liters per head per day, and the rate of filtration is 180 liters per hour per meter square, and the length of each bed we have assumed here is twice the breadth. We have to, and there is one more assumption, that one unit out of 6 will be kept at standby. First of all, what do we have to do for the given problem? Here the average daily demand is equal to the population into per capita demand, which is equal to 50,000 into 150 liters per head per day, which is equal to 7.5 into 10 to the power 6 liters per day. After that, we know that MDD is equal to 1.8 times of ADD from the our previous units. Is it equal to 1.8 into 7.5 power 6 liters per day, which is equal to 13.5 liters per day. So now the rate of filtration per day is equal to, it's given in 180 liters per hour per meter square, so it would be 180 multiplied multiplied by 24, it would be liters per meter square and per day, because it is in liters per day. Now we know that the total surface area is equal to of the filter required is equal to mtd by rate of filtration per day. So it is equal to, we already find out the mtd is 180. Also it will depend on the question. Sometimes you may be asked to find out the total surface area on the basis of average daily demand. So in that case you don't need to find out the maximum daily demand, but here we are using the concept of mtd. Usually these systems are designed on the basis of peak demand or mtd. So if something is mentioned, you have to follow the instructions given in the question. Now it is equal to 3.125 into 10 to the power 3 meters square. Now which is also equal to 3125 meters square. This is the area of the total filter bed. Now we know that it is given in the question that out of 6 units, one is kept as standby. So the total area would be 3125 upon 5, which is equal to 625 meters square. Now we already in the given in the question is length is twice of breadth. So if we are assuming the filter bed as rectangular in shape, it would be twice of b into b is equal to 625. So b is equal to, here the b will be equal to 17.7 meters, or you can say 18 meters. So L will be 36 meters here. Suppose here if the same question is asked to design, let's suppose design a rapid gravity filter. Suppose the population is given and the same data is given here, and then we are told to find out to design the rapid gravity filter, and we are not told to find out keep any unit as standby, or also we are told to ignore the, usually in this case of slow sand filter, in case of the backwashing, we remove the top layer head. But in case of rapid gravity filter, since there is a concept of backwashing, usually it's like half an hour is spent in backwashing, and we are told to ignore the time lost in cleaning. In that case, we can assume that the filter operated for 24 hours. The same concept will be applied, but suppose in the question is not given to assume that the filter units were not kept as standby. In that case, the total area will be 3125, and then we can proceed the same steps. The same concept will be applied. But if suppose the concept of backwashing came up, then in that case I will solve just a simple numerical. For these type of problem, what we have to do, first of all, data given here is we have to design a rapid sand filter, and which is treating around 4 million liter per day of water supply, which is receiving. Basically it will be treating this much amount of water. Now in this case, certain assumptions in this question, certain assumptions have to be made. We are assuming that the 4% of the filtered water is required for the washing. So this is the case of backwashing, and also around half an hour is being lost every day in washing the filter. So here total filtered water required per day is equal to 1.04 to 4 million liters. So if we are assuming that 1 liter is being treated and we are using more, I mean 4%, so it's 1.04 into 4, so which is equal to 4.16 million liters per day. Okay, now also if the filtered water, so the filtered water required per hour is equal to 4.16 million liter per hour, and we have assumed that the filter is operating for 24 hours and half an hour is lost, so it will be 24 minus 0.5, so which is equal to 23.5, so which is equal to, if we divide the two terms, it will be 0.177 million liters per hour. Now the rate of filtration is, we have assumed here is 5000 liters per hour. If it is not given, you can assume, or if the table is given, you can take from the table. Usually the rate of filtration for the rapid gravity filtration is higher than the slow sand, so which is equal to 0.177 into 10 to the power 6, because median is 10 to the power 6. upon 5000. Suppose in this question, I mean, it's not given that half an hour is wasted. In that case, we'll not be using this term, so it will be 24 hours here. And now this is equal to 35.4 meters square. Okay, now the length of the bed, we have assumed that it is equal to 1.45 times the breadth. Okay, now the total area here we got 35.4. Now now L into B is equal to 35.4, so it is 1.5 B into B is equal to 35.4. B here is equal to 4.85 meters, and L will be 4.85 into 1.5, which is equal to 7.286 meters. That's all for the two numericals that was on filters. There is one more thing that I forgot to point out in this question here, is that if suppose this question can also be solved in other way also. If suppose you are assuming that let in case 4% of the filtered water is required for washing of the filter, so we can calculate in the other way also. That case also the total water required for filter would be the same, so it can be done in another way also. Suppose we are assuming that the here you can see here that it is treating 4 million liters of water per day, right? Now instead of taking this as 1.04 factor here, we can say that okay, 4%, so we can directly multiply this by this 1. So this, suppose this is 1 and 2, so when we add these two terms 1 plus 2, so it will directly give us 4.16. so in some of the books you can see that they have separated the two terms. So they have first of all taken this 4%, so I directly, if you can see here, I have taken as 1.04 factor. So in that case also, if you add these two terms, it will be 4.16.